Press and hold the power button on the instrument for about 3 seconds. Switch on the tablet and open the MIRA Neo 3D application. Wait while the application connects to the instrument. In setup, confirm that the instrument is online. Then place the tablet on the instrument and rotate it until the magnetic holder locks into place. For calibration, place the instrument on the surface of your test object. Open B-scan mode and turn automatic velocity calibration off. Before starting the calibration, enter the current values for analog gain, digital gain, velocity, and frequency. You may pause the video now. The demonstration block used here is 500 millimeters thick. Adjust the zoom so that the expected back wall echo is visible within the displayed range. Press the instrument firmly against the surface and press one of the trigger keys. Adjust the digital gain to improve image contrast. Place the cursor on the first back wall echo and read the indicated depth. Adjust the velocity until the measured depth matches the known thickness. While calibrating the velocity, make sure that the A scan on the left never becomes oversaturated. Acquire another scan and verify that the measured thickness remains stable. Next, optimize the operating frequency. Start at 30 kHz and increase it gradually while observing the image. A higher frequency can improve resolution, but it also reduces penetration depth. Select a frequency that provides clear reflector indications without excessive noise. Here, the operating frequency has been increased too far. The image is dominated by noise, and the reflectors can no longer be distinguished reliably. Reduce the frequency until a clearer image is obtained. Remember that digital gain amplifies the useful signal and the noise equally. Digital gain improves the displayed contrast but does not affect the data quality. Now adjust the analog gain. Starting from the current value, increase it by 1 decibel at a time. Continue increasing the analog gain until the amplitude indicator turns red. A red indicator means that ADC overflow has occurred and the reconstructed image may be distorted. Reduce the analog gain by 6 decibels, as shown here, and acquire another scan. The amplitude indicator should no longer be red. Extend the zoom until the second back wall echo is visible. Then open the software time gain compensation controls, shown as S-TGC. Increase S-TGC gradually to compensate for attenuation with increasing depth. The aim is to obtain comparable amplitudes from the first and second back wall echoes. If the image becomes saturated, reduce the digital gain while keeping both back wall echoes visible. Once you have found the appropriate S-TGC value, return the zoom range to the depth required for the inspection. The graphic shows the rebar layout inside the demonstration block. On the surface, a regular grid marks the individual measurement positions. Open map mode and create a new measurement. Select the view that you want to use during data collection. Set the scan direction. Then set both the X and Y step to match the marked grid. Check the starting position, step size, and scan direction in the Map Manager. The X and Y step values define the distance between measurement positions, while the scan direction setting indicates where the instrument should be moved next. Place the instrument at the first grid point and align it with the markings. Keep the instrument flat and stationary before taking the measurement. Press one of the trigger keys to acquire the first point, then move the instrument exactly one grid step in the direction shown on the screen to record the next one. Continue point by point until the planned area is complete. Switch to the volume view and wait for the map data to be reconstructed. In map mode, you can select different grid types. In grid cell mode, each B-scan is displayed individually. In grid row mode, a compound B-scan is displayed showing the selected side view plane through the volume. In grid column mode, a volume view for the selected column is displayed. In full grid mode, the entire inspection volume is displayed in a single view. Even after completing the measurement, you can still change parameters such as the zoom range or velocity. Keep in mind that recalculating the data may take some time. You can switch to ISO rendering and change the ISO level to isolate the strongest reflectors. Open the file manager, save the map measurement, and enter a clear name so that the data can be identified later. Should this pop-up appear during or after the measurement, press yes to avoid losing any data you have already collected. To transfer the measurement data, connect the tablet to the computer using a USB cable. On the tablet, open the USB settings and confirm that the connection is set to transferring files or Android Auto. On the computer, open the tablet's internal storage, then open the A1040 MIRA 3D folder. Open the folder on the computer where you want to store the measurement data. For MIRA Neo Desktop to recognize the data, the destination must contain the 4-folder structure shown here. For the first transfer, copy all 4 folders from the tablet to the computer. Paste them into the destination folder. Once this structure exists, you only need to copy each new measurement from its folder on the tablet into the folder with the same name on the computer. Confirm that all 4 folders are present. Now open MIRA Neo Desktop. In Setup, select Data Path, then choose the folder that contains all 4 data folders. Open Map Mode, select the measurement you want to evaluate, and wait while the map is reconstructed. The measurement first opens in Planes Rendering, which displays cross-sectional slices through the reconstructed volume. Select MIP to display the strongest signal along each viewing direction. INTROVIEW Concrete is another application you can use to open the measurement. Click Open and navigate to the folder containing the copied measurement. Select the correct instrument type, then open the measurement file with the .m3D extension. Wait while INTROVIEW loads the 3-dimensional volume. Drag the model to rotate the view and see the measurement from different angles. Use the controls beside the color scale to adjust the displayed amplitude range. If the application does not connect automatically, press the button to the left of the refresh button, as shown in the video. A pop-up will appear showing that the expected Wi-Fi network is named A1040 MIRA 3D. Press OK to open the list of available Wi-Fi networks, then select the network that corresponds to your device. Once the connection has been established, place the tablet on the main unit and rotate it until the magnetic holder locks securely into place.